Okay. This is 6-2. Okay, so the first section in this unit was all about quadrilaterals, but now we're going to get a little bit more specific. In this section, actually in the next two sections, we are only looking at the branch of quadrilaterals that's your parallelograms. Okay, so this is the only shapes we're going to be working with for the next two sections. Okay, so make sure you have this handy because we will be adding some theorems and properties to this chart. Okay. First thing we need to talk about is one vocabulary word, which I've kind of already talked about. Okay. Consecutive means in a row. Okay. So when we're talking about a shape, and it doesn't even have to be a quadrilateral, it could be a pentagon or a hexagon. If I'm talking about consecutive sides, okay, those two would be consecutive because they're in a row. Another word they could have used is adjacent because they're also next to each other. So adjacent and consecutive, you'll see me use those words kind of interchangeably. Okay, the reason why this is important is because you need to know that in a parallelogram, and this isn't a theorem, I don't know why it's not a theorem, it could have been a theorem in the book, it's easily provable. But it's not, so just one of those properties that you need to know. Okay. Consecutive angles of a parallelogram are congruent. And the reason for this is, like I said, it would be really, really easy to prove this. I don't know why they didn't and just call it a theorem. If you have a parallelogram, then you have parallel sides, which makes this a transversal, which makes that angle and that angle, same side, interior angles, which means they are supplementary. Okay? So that's the reason behind the consecutive angles being supplementary, and it works with any two sides of the parallelogram because it has two pairs of parallel sides. Okay. So an example of this would be if I said this angle was 3x plus 1 degrees, and this angle was 4x degrees. How would you solve for x? Well, supplementary means that they add up to 180. You've done this all year, so hopefully it'll start to get a little familiar to you. Add up to 180. Supplementary. Combine your like terms. Subtract 1. And then we would divide by 7. I'm not a human calculator, so I'm going to do this on a calculator. And that equals 25.6. Okay, so that's one way you could use this property. Consecutive angles of a parallelogram are supplementary. So, all of the properties and theorems that apply to our shape are going to go in this space right here. Now, you're going to need to write small because there's lots of them for the parallelogram. Okay? And we're going to do a lot of abbreviating as well. Consecutive angles are supplementary. Now, if it applies to this one, then it also applies to all of these below it, right? Okay. So, all properties of parallelograms. So if I write it here, then it also applies to this shape. Also, if I write it here, it applies to this shape. And then for the square, anything I write in either one of these two shapes also applies to this shape. Okay? Alright, back to our notes. Alright, we've got 3 quick theorems. I'm going to try to go through this quick, because I know I promised yesterday's notes were short and I ended up talking forever, even though I didn't write that much. Alright, theorem 6-1. Opposite sides of a parallelogram are congruent. Okay, I actually will have a hands-on way for you to understand this theorem in class when we get to class time. But we're just going to write down the thing and see an example at first. Alright, so you can obviously, some of you already know what this example is going to look like. How would you apply this theorem to a problem? Okay, obviously if I tell you that this is a parallelogram, and this is 4x plus 2, and this is 5x plus 1, there's one example. Or this is 3y minus 15, or this is 2y plus 3. Okay, if they're opposite, that means they're equal. So that means I can set that equal to that, because they are opposite. So 3y minus 15 is equal to 2y plus 3 plus 15. 3y equals 2y plus 18. Subtract 2y. And get y equals 18. Okay? You can also do the same thing for these two. Since they are opposite, they are equal. Now again, this only works for anything that's a parallelogram. So if you're dealing with a trapezoid or any other quadrilateral, it would not work. Okay, that's what I'm talking about the other day, about making sure you're following these examples correctly. You can't just follow them blindly. Because if your picture is not a parallelogram, then you can't do what I'm doing here. So that's very important to understand when you're following examples, is that you don't want to just follow them blindly. Understand why I'm doing what I'm doing and whether or not that applies to your particular situation. Okay? I've said this before, that's why geometry is harder than algebra, is because every single problem is different. Okay? So there's theorem 6-1. Sorry, I didn't realize you couldn't see that. Again, I just set these two equal and solved. Okay, if you need a pause to copy that down, that's fine, but I'm going to continue on. Alright, theorem 6-2. Can y'all see this? Nope. Okay. Theorem 6-2. Opposite angles of a parallelogram are congruent. Okay. Again, I have a demonstration in class that I'll show you about why this is true, but for now, for the notes, I'm just going to show you some quick examples. Okay. What example was I doing? Oh, yeah. Okay, again, if you have a parallelogram, remember this only works for a parallelogram. So 6y plus 4 degrees and 3y plus 37 degrees. Then you know that opposite angles are congruent because of this theorem right here. Okay, so if they're congruent, then you can set them equal. Congruent means equal. It's just a different form of the word. It's used in a different context, but it means the same thing. Okay, and I get y equals 11. Hopefully that's what you got. Alright, and then the last theorem we're going to do today is theorem 6-3. Okay, well, let's talk about this theorem for a second. Overall, it's a pretty simple theorem, but there's a lot of vocabulary in this theorem that not everybody always knows. Not everybody knows what a diagonal is. Let me get some scratch paper out. A diagonal is any line that you draw, and it doesn't matter what kind of shape you're doing. I know this section's about parallelograms, but you can apply this to any shape. If I have a shape and I draw a line from one corner across the picture to the other corner, that is considered a diagonal. Okay? And a parallelogram, it would look like this. There's only two diagonals you could draw, that one and this one. Okay? So that's what a diagonal is. Another vocab word in this theorem is bisect, and although that is a Unit 1 vocabulary word, and it's shown up in Unit 3, and it showed up in Unit 4, and it showed up in Unit 5, I know some people still struggle with the meaning of it. Bisect means cut in half. It means it makes it into two congruent sections. It creates a midpoint. I could go on and on. There's a bunch of different ways I could word this vocabulary word, or the definition for this vocabulary word. Bisect means cut in half. Okay? So, an example of this problem would be if I had this picture and I had that diagonal drawn and that diagonal drawn, and this is 2a minus 8, and this is b plus 10, and this is a, and that's b plus 2. Okay? Bisect each other. Okay? That means this is a midpoint of both lines. It does not mean that these two are equal. Okay? It means that this is bisected so that those two are equal. Make sure you're setting the correct things congruent. These two are equal, not those two. Same thing over here. This one is equal to that one. Okay, because this is a midpoint. It's bisected. So b plus 10 is equal to 2a minus 8. You cannot solve either one of those equations by itself. Okay? But you realize that this one is already solved for a. It tells you that a equals this. So what can I put in place here? This is called the substitution method. We've used it before this year. This goes in to that spot. So everything else in this equation remains exactly the same, except instead of a, and again, anytime you have an equation, you better put it in parentheses. A lot of you won't, and you'll get this wrong. Okay, this whole thing needs to be put in parentheses when you plug it in. Now we can solve this. Okay, again, I'm going to show you the by hand version. This is a pretty advanced algebra problem for not really my pre-AP classes, but definitely my regular ed class. This is a pretty advanced problem for you guys. So obviously, if you needed to, you could solve it on the calculator once you got it to this step. Okay, on this step, you could go to the calculator, but you do have to do the subbing in correctly. You have to put it in parentheses. Okay, so first I distributed. Now I'm going to combine my like terms. 4 minus 8 is negative 4. Now I'm going to move this b over. So 10 equals b minus 4. And then add the 4 and I get B equals 14. Okay. Now I still haven't solved for A, so now I need to take this and plug it back in here. So A equals 14 plus 2, which is 16. And there's my two answers.